Hello and welcome. This is a talk that I presented in Devoxx Morocco in 2023 regarding preventing security vulnerabilities on a web application. I want to apologize about the quality of the recording in general, both audio and picture, but since the organization was not recording the sessions, I had to do it on my own using my mobile phone. I hope you will enjoy and I'm looking forward for your comments. Thank you.
Okay, let's start. Thank you all of you for joining. I'm Alexius Diakogiannis. I am a senior Java software architect in the European Investment Bank, the biggest bank in the EU. It is an EU institution that actually funds the EU and all the major projects of the EU. And I'm going to talk to you about how to prevent security vulnerabilities in a web application. You've heard in this conference in several talks, several stuff about security. Okay, you heard about threat modeling, you heard about the OS top 10. What I'm going to show you now is a complete process from requirements to the deployment. So I will put everything together. So take notes and feel free to interrupt me for any questions. So let's start. Who am I? As I told you, I have 20 years of experience in high complex and secure projects as an architect, and I'm also a member of the Tech Advisory Board member. I'm writing a book about high performance Spring, and I'm mentoring the volunteering by principle. So if any of you have any questions, you can or you want to discuss something, you can reach out to me here on my social network. I'm glad to everyone, and I'm happy to help. So, a small introduction. Companies usually invest a lot of resources in order to be able to defend their applications. Okay, in order to be able to prevent attacks, what do? They usually develop a software development lifecycle. Okay, a cycle that will be able to take requirements and make them into an application. The process I'm going to describe to you now is based on the Rational Unified Process, RUP, which is a process that I will demonstrate later on, which is very similar to the waterfall that you are going to, that you're probably using in your companies. What I'm going to demonstrate now applies to every management process, for example, Agile or any other you are using. I will help you with calculating the risk. I will then describe methods for securely writing code and how to educate your team, which is equally important. I will show you how to use AI in development and how to monitor your code after this is in production. Excuse my voice, but I have a severe cold. So, back to basics. What is a web application? We all know that a web application is a client, a web server, a bunch of application servers, and a data storage, which can be a DB, an MDM, or something else. Okay, and the communication between them. We are going to focus on this part, on the red part. This is what we care. We don't care about the security of the client. The challenges in web application security are the following. Most of the web standards out there are informal requests for comments. These standards are usually not well defined, and of course, the internet is fast, so it's not easy to collect them all. So these situations makes the modeling of the web, of the whole web, almost impossible. But is there any way to be able to model how we secure a web application? Rational Unified Process, or RUP. Again, I will point out that I'm using this as a baseline. You can apply what I'm showing to you in any project management process that you're using in your company, for example, Agile. Now, a small introduction. It is a software engineering process that provides a disciplined approach on assigning tasks and responsibilities within an organization's development. Okay, the goal is to ensure that quality of the software meets the quality of what the users expect. Now, the IUP divides the software development process into 4 stages. The inception stage, which it is actually a helicopter view design of what is going to be done. For you that are applying Scrum, this is your epic. This is the stage that you design your epics. The elaboration, okay, where there is a detailed plan of how the software will be developed. For the guys that apply Scrum, this is the design of your sprints. Okay, the construction, of course, and the transition where the software is going live. Now, RUP defines 6 core development principles. The business modeling, which is the part of the team understands the business and the requirements. The actual requirements, which the team defines the specific requirements for the system. Analysis and design, implementation, and testing. For you that apply Agile and Scrum, this is what you actually do in every cycle that you do. So you see that what I'm showing you now can be applied also to other strategies that you might be using. Now, the approach, as I told you before, is what we need to do: design, QA test, continuous review and feedback, and of course, change, involvement. So, if we want to secure a web application, when do you think we start? We start with penetration testing, with code reviews, with scanners, with firewalls. We have everything here, okay, in this conference. Well, no. Okay, the place that we start is secure requirements. So we need to start securing the web application before we actually start building the application. What does this mean? Okay, how do we collect security requirements? First of all, we need to involve the security experts early in the process. We need to involve them when we are collecting the requirements. We need to use a risk-based approach, and I will show you how we're going to calculate the risk. And we need to consider the different types of attack that this application might take. Okay, the principle for that and our guideline will be the OWASP top 10. And yes, trust me, business requirement can violate the OWASP top 10 principles, not only source code. So, some design patterns and practices that you need to use when you're collecting secure requirements. First of all, defense in depth. You need to always keep in mind that you need to use multiple layers of security in order to protect your application. For example, authentication, authorization, encryption, firewalling in front. You need to use always multiple layers. Don't put all your eggs in one basket. You always need to use the least principal approach, which means that everyone needs to have only the necessary privileges in order to do the work. Deny by default, which means that everything is denied unless instructed otherwise. Zero trust, which means that you trust no one, no other resource, no nothing. You only trust what you have inside your application. And of course, threat modeling, which is a process in order to be able to identify what are the potential threats of your applications. So your security experts will do that for you. Now, let's continue. You have the requirements. What are you doing with them? You need to document them, and they need to be very clear for the developers. So the developer, when he gets the requirement that involves security, needs to know exactly what he's going to do. In the end of this presentation, I will show you a counter example of that. So keep that in mind. Now, you need to review the security requirements with your stakeholders. Many cases, you have secure requirements, but the secure requirements actually destroy the experience of the application. So you need to review them with your stakeholders and take actions and decisions that both doesn't violate security but doesn't violate the usage of the intended usage of your application. Now, some thumb rules when you're going to do that. Be aware always of the sensitive data that will be stored or processed by the application. Keep them always in mind. Consider the different types that this data can be compromised and prepare of what you're going to do if these data are actually compromised. Make sure that your requirements specify how the data will be protected. Okay, are they going to be encrypted? How they're going to be protected? And consider the different ways that the application could be used to attack other systems, because this may happen. Make sure that the requirements also specify how the application will be secured from all these attacks. And don't forget to audit training, which is something that I've seen a lot. So, let's continue. The holy grail for what we're going to do and what you're going to do to secure your application must always be the OWASP top 10. You've heard about this in this conference in at least 3 or 4 talks, so I'm not going to go through the rules. You just need to know that OWASP top 10 is the list of the most common vulnerabilities. If you don't already know that, then I have bad news for you. You need to go and study them, because it's very important what you do. Now, how we're going to calculate the risk. OWASP has a risk rating methodology, which helps us calculate a risk when a vulnerability shows up. So there are several stages in this calculation. The first one is the identification. What is the vulnerability? What is the attack performed? And how much damage can it do? And what is the potential business impact? Because in the end of the day, whatever is done in our application for our company has a business impact, and it's very important, and this is the most important for the company. What are the threat factors? What does this mean? That how much skill is required? For example, if you need to be a high-end hacker to be able to make the attack, and your application is not that important, maybe the risk is lower than you think. What are the opportunities and what is the motivation behind the attack? And last but not least, how much attacker volume is needed? For example, if in order to be able to perform a DOS attack, I need 1 million of workstations, it means that I need 10 bitcoins to do it, which means that I need a lot of money. So maybe the potential of this to happen is lower than expected. What are the factors of the vulnerability? Is it easy to discover? Is it easy to use? And what are the technical impacts? The technical impacts of an attack or vulnerability are always 4. Is the loss of confidentiality, the loss of integrity, the loss of availability, and the loss of responsibility. There are always these 4, and always keep them in mind when you're evaluating a bug or a threat. Now, last but not least, what are the business factors of the attack? What is the potential financial cost? What is the damage to the reputation? And the damage of the compliance, for example, is it a GDPR issue, which will get me a very big fine? And what is invasion of privacy? In other words, it's this cycle. Okay, you determine the risk of the severity with the pillars that I've shown you before, and you put the tag low, medium, or high. You decide what needs to be fixed, okay, and you fix it, and then you do model adjustments if needed, okay, in the way that you're going to calculate your next vulnerability. And trust me, this works pretty well. Now, development. So, The path to glory is this. You write using secure coding standards. You verify what you've written with code reviews and other practices that I'm going to show you. You ship test the application, and in the end, you improve your effort. So, let's start. Secure coding and code review mix and match what they usually see on the duty-free applications. Why do we need software quality in order to be able to secure an application? Because high quality software leads to most likely a secure software. Now, if you need to review your code, okay, you need to do the following. You need to be able to follow these questions. Am I able to understand my code easily? Okay, you all remember the meme in the internet that says that only God knows what I'm reading. Are you able, is the company according to the company standards, the code? Excuse me. Is the same code repeated more than once, and why? If you're using low-code, no-code systems, these three principles apply to you as well. Okay, in a low-code, no-code system, you should be able to answer these three questions. Can I easily test and debug my code? Have I written test for at least 65% of the code and 80% of the if case statements? These are my numbers, okay, my preference. Is this method of class too big? Okay, maybe it doesn't have a lot of responsibilities. Maybe I need to cut it down. And the two most important things: does it violate any of the OWASP top 10 rules? And the second, does it violate any secure coding principles or requirements that we saw on the beginning of the presentation? Let's move on. Now, how do we code review? First of all, my favorite, over-the-shoulder review. Okay, code review is a process where someone is the moderator and the other one is the facilitator. Okay, for me, everyone can be a moderator, even a junior developer. A junior developer can review pretty much code and sit beside you and see things that you, with 25 years of experience, might miss. Okay, over-the-shoulder review. You come, you tap the shoulder of the developer, or you ask them to share the screen, and he walks you through the code that he has written, and together you try to find out, okay, if there is an issue. It's based on the rubber duck principle for whoever knows the principle. Of course, you give notifications, okay, when you put the erase here, and the viewer is assigned automatically. Another favorite of mine is pair programming, the extreme technique where two people are sitting on the same computer. The one is the driver that writes the code, and the other one is the observer. But be careful. If you're going to follow this, change the roles every approximately 30 minutes. After 30 or 45 minutes, if you don't change the rules, usually the one developer is writing and the other one is playing with cell phone. Okay, so make sure that you switch fast enough before this happens. Last but not least, the static code analysis tools, which I'm going to discuss later more analytically. Now, the golden and most important rule of the code review is be polite and educate people. Okay, don't be rude in your code review. Specifically, in all of my teams, I apply this algorithm. If a code reviewer is aggressive, is making bad examples, or he has a code attitude syndrome or something similar, then remove him or her from your team, even if he is the best resource you have. And trust me, this is the most important part, because you need to have your team happy. Okay, because happy developers and a happy team are way more collaborative. And you have a pretty good chance that you will have security champions in your team. which means that some people of your team will be able to do this extra mile and focus more on security and help the other team, but they need to be happy. Okay, happy developers write better code and they most probably stay within your company. So your investment that you're going to do, okay, in the education of these developers will stay with you if they are all happy. So creating a positive environment leads to better and secure code. Now, I'm going to talk to you about some specific secure coding guidelines from my experience. First of all, sanitize all your URLs and APIs, okay, even if they come from sources that you think you can trust. Okay, use a centralized authentication, okay, like OAuth2, and implement the proper authorization, and avoid custom implementations. Use your framework. Prefer using UUIDs over increments, okay, so that you can prevent enumeration attacks. Secure your queries, even if you use a URL. Many, especially junior developers, are telling me, but I'm using Hibernate. Well, it has nothing to do with it. Okay, especially if you always use parameterized queries, even if you trust your source, and have a logging strategy. Okay, which means avoid exposing in your log files, not even to the user. Okay, too much information which you don't require. Log securely and not sensitive data. Sanitize the output of the log because in order to prevent attacks in your OS. Okay, and be careful not to log too much because you might end up attacking your own system within the of service. Nice to have is your logging media to have anti-forgery measures. Don't forget to audit trail, of course, and audit both success and failures, okay, when the user logs in. Of course, enforce secure communication, implement rate limiters and exposure backup with jitter, which we're going to discuss on the next slide, okay, which is equally important. CSRF tokens, security headers, of course, okay, remove commented code because it may include stuff that can expose sensitive information. And if your application handles file uploads, don't validate them by just using their exceptions. There are libraries out there like Apache Pika that can help you. And always store them in a secure location. Last but not least, know your limits. Know the limits of your storage location. And implement pseudo-random fault instructions in order to be able to bypass these limits. And ask your vendor, okay, in order to find out these limits. Now, rate limits and exponential backup with jitter. Imagine that you have an application, okay, that's down, a service that's down, and you are hitting it with a lot of requests. At that particular point, you are actually denying any other people, okay, from accessing this application. When this service in the application is up, it needs to have an exponential way of answering to whatever request it is getting, so that it won't get all the requests at the same time. To be more precise, imagine that you have an application which is out of your control that has a loop, okay, inside, asks of 100,000 contracts, and it asks one contract at a time. So it's actually hammering your application. What will happen? You are dead. Okay? You're actually dead. What you need to do is to use libraries like Resilience.j, Packet.j, Comp, which is a Comp, or ask your provider so that you can rate limit the requests, but also distribute them so that they won't have everything at the same time and kill you. So, the sorcery of AI code generators. We all know that we use generators for productivity because they give you code refactoring, auto completion, something very handy to create documentation, okay? And they can do security, vulnerability detection, they can suggest secure practices, they can do a lot of stuff. Okay, and the main players are Copilot, Tab9, ChatGPT, Cody, Code Whisperer, and PAR. What you need to take photo of is this. So, I made a small table here so that I can help you, okay? And to help you in a bit of that, if you are using AWS applications and you're using, for example, Cloud9 or JetBrains Cloud ID, okay, then go directly for AWS Code Whisper, but always use either PAR or ChatGPT. So use them together. For the rest, okay, if I want to use something open source, go to Copilot, and all the others that are in company or have a budget, okay, they can evaluate the other plans. But this is what I usually do. I usually use one of them, okay, and in addition with BART and ChatGPT, or ChatGPT. So, the pitfalls, okay. Always test the code that is generated by AI code generators, okay, because they are still immature, and you need to use them in conjunction with other security tools. So don't put all your eggs in one basket and never bypass manual code review. Now, the static code analysis tools, another sorcery. The benefits of the SaaS tools is that they take your code, they detect bugs, they improve quality, okay, they reduce risks, okay, and you are confident that your code is okay. So they actually use either within triggering within your ID or they are triggered by the SCM. However, you need to use SaaS tools always to educate your developers. What am I doing in my teams? I group all the significant security findings and I organize retrospectives specifically for them and educating the team. And I even other developers, security champions that we talked on previous slides to do that. Or I take some milestone findings and I'm making one-on-one sessions with whoever is needed. So the goal is to educate the team so that you can produce secure software. Fourth opportunity. This one. How to choose the right static code analyzer. These are the major players of the market. Okay, but another good photo opportunity is this. So, if you're on an open source, or if you want to use open source project, and you need something which is both online and offline, you can use SonarQube, on-prem for the most advanced users. For the cloud users that are doing cloud development and all the code is on the cloud, there is a new player from JEE.gr, which is called Codana, which is quite good. And for the commercial part, those who are on a medium budget and they want to use something which is also online and offline, well, they can, there's nothing that we can do. Okay, but for online only, you can use Snake, which is pretty good. It lacks some features, but it's quite good. Or the ones that are on a high budget and have security experts within the company, you can use one of the rest, they're equally good, all of them. So, we have gathered the requirements, we have written the code, okay, we have secured the code. Are we done? No. Because we are using open source and other libraries around us, dependencies, okay, and there is a pretty good opportunity that one of them, okay, might have a vulnerability. For example, the Log4j issue. What are we doing? We use the software composition analysis in order to prevent, as it is called, the supply chain attacks. Actually, up there is doing a talk about it right now on the next group. specifically for that. So, what do? They improve security because they check the vulnerabilities of the satellite components of the application. Again, another photo opportunity. These are the common SCA tools. Okay, Nexus, Synopsys, the white source, Sneak, again, dependency track, dependable, and VOWASP, dependency checking. You also might be interested in this photo opportunity, again, which I made it clear for you so that you know what you're going to follow. So, if you want to use something free and open source, you go to VOWASP dependency checker, Sneak, or dependable. Be careful of VOWASP dependency checker because it lacks many features. What I usually do is that I include VOWASP dependency checker within my POM.xml file, so it runs on build time, and in addition with another tool. So, for the paid ones, again, of course, we have Sneak, White Source, and Sonatype, and Synopsys. Okay, so I hope this will help you. Now, we secured our code, we secured our components, we are ready to ship the application. What do? We do penetration testing. Okay, we ask the bad guys. The penetration testing or Dust tools, what it does? It takes the application, it treats it as a black box and tries to attack it. It tries to attack it with using two ways. The first one is the active, and the second one is the passive. Active means that it makes directly attacks to your application and tries to find vulnerabilities. Passive way, it monitors the network and it tries to find vulnerabilities within the network regarding the specific application. What it doesn't do sometimes is that it doesn't detect business issues. For example, business decisions that you have made that actually pose a security threat. This is why we need secure requirements that we discussed in the beginning of this presentation. Okay, and also will not detect bad design because we need threat modeling for that. Again, photo opportunity. These are the common Dust tools. Okay, the easy ones are the ones that a developer can use. Okay, is ZAP and the Burp Suite. And the Detectify Community Edition also is cloud-based. Something that I give my developers to do is because the execution of these Dust tools are usually pretty expensive in terms of time. I tell them to run them on the subset of the features that they have developed, just in case they haven't created a vulnerability that hasn't been detected, okay, by the whole process that we discussed. Now, we secure the code, we secure the requirements, we secure everything, we did a penetration test, we shipped this to production. Okay, is it over? Well, no. Okay, because what happens if vulnerability, okay, comes after the shipping of the production? Okay, we need to use the SAS and the SCA tools frequently on the code that is runs in production, even if the code is stale, even if we are not developing at that particular time. Okay, because, for example, again, Log4j, you have an application, okay, it's out there, it's running, you were not maintaining it because you didn't have to, okay, and you have this vulnerability. If you don't run the SAS and the SCA checks frequently, you will never find out. So, you need to have regular penetration tests as well, and a solid monitoring process for all the above. And when you find a vulnerability, what do? You calculate the risk, as we discussed in the beginning of the presentation. So, now we know all the process. I will show you a counter-example app and how the guys that developed the app did almost everything wrong. I was about to show you a different application, but we had elections in Greece. Okay, so the government, so the government decided to build an application. It's an actual example, so that the candidates and the parties will go and register their announcement there. Okay. So I was expect that this application is secure because it was built by a major Greek company. It has a centralized notification. Okay, and there were a swarm of applications. Okay, that did almost the same thing. Okay, I expect it to be secure, to have a secure implementation and testing. Well, I was wrong. Okay, I was wrong. What did this application do? Okay, a candidate or a party was logging in, it was registering his details, and then he approved or rejected his nomination. Okay, it was something very simple. Okay, what can go wrong? Correct? Well, this is an actual screen of the application with my data there because I was a candidate. When I tried to verify, I realized it's not visible very much here that my candidate code actually existed in the URL. The URL was something like that. Okay, so I was tempted and I said, okay, if I change number 56099 to 56000, what will happen? Guess what? I saw another candidate. Okay. And not only I saw another candidate, if I wanted, I was able to throw him out of the elections. Which means that I was able to destroy the whole elections if I wanted with a very, very, very simple enumeration attack. Again, this is a government application built by a major company. Okay, so what did I do? I notified them, okay, and tried to fix the issue. So I did several communication attempts, which is the monitoring process we explained to you before. Okay, and I wrote to the minister, I wrote to the company, I wrote to everyone, and the reply was that it was not their responsibility to fix it. Okay. Now the issue is fixed. Okay, after several written communication, this is why I'm presenting it publicly. Okay, and of course the elections are over. So, what went wrong with this application that is aiming for a second? Did they have secure requirements? No, because if they had secure requirements, they would know that this enumeration must not exist. The ID at least must be public, and one user cannot see the data of another user, but inside the requirement. Because if it's not inside the requirement, the developer might not see it, the code reviewer might not see it, the tester might not create a test for that. Okay, the penetration testing will not get it, and in the end of the day, it will go to production as it did. Secure design? Of course not. Okay, the design was not secure by chance. Code review? Most probably not, because I cannot imagine a senior developer seeing that query and without authentication, okay, and saying, yeah, seems okay, good job. SaaS tools? Yes, they most probably used SaaS tools because I tried to review the code behind the UI and I saw that it was quite well written, so they most probably used that. But SaaS tools don't detect business issues. Testing? Maybe they did, maybe they didn't. And I'm saying maybe because I'm giving the benefit of the doubt to the tester. Because if he doesn't have a requirement about authorization and the tester is not that senior, he might not have pinpointed the issue. If they use DAS tools, the penetration testing, maybe, but as we said before, DAS tools do not detect business issue, and this is actually a business issue. This enumeration attack is within the gray zone. And if they do a risk assessment, no, because when I told them that they have a critical issue that can destroy your elections, and this is actually the wording that I used, the first reply was, this is not a responsibility, call someone else. Okay, so In conclusion, what we are doing, we are using secure coding standards, code reviews, secure deployments, as we said before, okay, and doing that improvement, but we need to insert in our process automation and education. We need to be able to educate the developers in order to produce better code and automate whatever we can. If we are able to have a structured process, whatever process this can be, it can start from waterfall, it can start from agile, it can start from whatever you want. And you include all the things that we talked about, secure requirements, risk methodology, SaaS, and task tools. Okay, and in the end, a proper feedback mechanism with education, you will be able to produce secure software. So you need to write, you verify, you ship test, and you improve. Okay, that's the process that you always need to do. Okay, keeping in mind the tools that I've shown you before. Thank you very much.